Good evening. My name is Sam McGlynn, November Mike, 5 November. I'm going to say right up front, I'm not an expert on this topic. I've read the book, you know, I've taken a real interest in this, and hopefully I've picked up a few nuggets. But I'll say right now, if you're watching this on YouTube, go watch the guy who wrote this book, Grounding and Bonding. He's got a great video on this, which I borrowed from heavily. Hopefully he doesn't mind, because I'm plugging his book and telling him to go watch his video if you're watching that. But hopefully this is a good opportunity to discuss some of the points that are made there, and I've got a little show and tell with some of the pieces that are referenced in the.
What's his name, Sam?
Ward Silver, N0AX. So he's also, besides writing this book, he's also the primary editor for the ARR handbook. So the guy really knows his stuff. And definitely go look at the resources that are found there. Okay, so the agenda, kind of like what are we going to talk about, what are we not going to talk about. We're going to talk about some of the principles, also get into RF management, and show some examples of kind of like, what is a typical, maybe not so great setup, what's better, and a best objective model. So I think that can be kind of useful to kind of compare your Hamshack to that and say, okay, well, maybe I can do some things to make it even better, and some do's and don'ts that I pulled out from some of these resources, as well as a link to a number of resources, including the Ward Silver's video. So this is really an introduction. I'm not an electrician. I'm not an expert on this. There's some, like I said, there's some really good resources here. I'm going to focus specifically on the Hamshack. I'm not going to get into, like if you read this book, there's also talk about portable operations, mobile operations. I'm not going to get into that. A lot of the same principles would apply there, but there's definitely some nuances there that I would just direct you to other resources for that. And this is really not a how-to, but really kind of introduction to these principles as we talked about earlier. Okay, so let's start getting into some definitions. Ground. It has different meanings depending on who you're talking to. So if you're talking about AC or lightning, you're talking about a connection to the physical earth. It also, if you're dealing with circuits or RF, it's just the local reference voltage. What is the reference voltage? It's not necessarily the earth. It can also be used in terms of like a verb. To ground something is to make that physical connection to some whatever reference potential that you're whether it's the earth or the common circuit local reference. It's not some magic sink to pour all your RF or lightning and make it safe, so it's not useful to think of it that way. Some other definitions. Ward Silver kind of makes a point about this. RF ground, it's not a real thing. Really what you're talking about is a local reference potential. Single point ground, you'll hear that if you're talking to someone like an electrician, they're going to be thinking about it in terms of the service panel, but if you're dealing with your Hamshack, you're probably talking about a single point ground panel. Well, all your connections that come in and out of your protected zone, your coax, your rotor control cables, your non-ham stuff that's not utilities that are coming in, that's another point what they would discuss there. So as opposed to grounding or ground, bonding is the physical connection of 2 points to get them to this, so that they're at the same voltage potential. And the whole idea is that all the voltages go up and down together at the same time. Serves the purpose of preventing shocks and hazards from voltage differences. It also helps prevent destructive voltage differences from lightning surges, so those transients. It also limits the current differences between devices from voltage differences. This due to RF pickup. So if you get RF in the shack, this induces current. Current is like, why do I care about that? If you get noise or RFI in the shack, that's why you care. Also, it's really not hard to do. It's just connecting everything together with short, low impedance cables. It also works for AC safety, lighting protection, and RF management. And we're going to get into some of those details going forward. Continued. So just some basic stuff. Just some, whether it's copper strap, 20 gauge copper strap, or heavy wire, number 14 or larger. Flashing, I brought an example here. This is something, I went ahead and bought this at DX engineering, but if I'd read more about it, I probably wouldn't have done that, frankly. This is probably a really easy solution. It's nice because you can kind of connect your devices to this single piece here and physically put your radio on it. But you can also just, and you'll see an example later, where you can just get a sheet of aluminum flashing and put it on the back of your desk and just pile everything on there and connect everything to it, and that's going to be definitely quite a bit cheaper. Also flat weave or tin braid. I've got a little piece here. You can kind of see what we're talking about when we say tin braid, and I'll just kind of pass that. I know maybe some of the newer hams haven't seen what that is. And so the next topic is AC safety ground. So grounding for AC safety has, like you might hear about it with different names. Equipment ground, third wire ground, or green wire ground. Purpose is provide that AC common point for a fault current. So if you've got your GCFI outlets in your bathroom and you've got some water in there, it allows it to short so that you don't get electrocuted. And it will pop the breaker so that, again, which will stop the current and prevent serious injury, hopefully. It also helps to stabilize AC power system voltages during faults and transients, so like if lightning hits. And the key point here, and they kind of get into some of the details here, the bottom line is to make sure you follow the code. There's a lot of books or resources out there how to do some of this wiring. You can hire an electrician if you're not comfortable doing that. This is just a schematic which kind of shows what we're talking about. The service common point and the connections back to the utility transformer. And you can see the ground electrode there on the right and how that's connected. So lightning protection. In the second version of this book, one of the things they made a point to change is that this idea that you can control lightning. You can't control lightning, right? The whole idea with lightning protection is you're trying to steer it or influence it to stay away from the zone you're protecting. When you talk about lightning, what is that? It's a single, like, large DC pulse that goes from the sky to the ground or the ground to the sky. But that connection, ultimately you want to get that to dissipate that charge into the ground. You want to minimize inductance, and they make the point about in towers, just the voltage difference from the top of a tower where lightning hits to the bottom is something like 100,000 volts. So that's relevant for things like making sure that your coax is bonded to tower at least every 50 feet, and we'll get into some of those additional details. Additionally, with lightning protection, the whole idea is you wanted those paths to remain outside your residence. You do not want to make it easy for lightning to go through your station. So if you kind of keep these principles in mind, then when we actually get into some of the practical measures, hopefully it'll make more sense. So single point ground panel, or SPGP. So physically what we're talking about is some type of small metal panel that's usually mounted outside, and there's ones you can buy that does this, that all your connections are mounted to this, and you can see all the cables, they're connected through lightning arresters, or if they're rotor control cables, there's connections to short to the panel. But if there's some type of a transit, like a lightning strike, that all of those protection measures will fire at the same time. That's thus preventing the voltages from differing and potentially creating a hazardous situation. And what does it do? It bonds all the grounds of all the entry paths, and ultimately it's one connection down to the perimeter ground. And you can see that here on this side, right here. So from this panel down to this perimeter ground, when we talk about that, we're talking about your grounding electrodes or ground rods, which you can see are also bonded together. And then one thing I also want to point out is the protected versus unprotected. And this is something we're going to get a little more detail about the protected zone next. The perimeter ground. So you can see here just an objective model of a house. You've got your electrical panel. That's your utility, where utilities are coming in. There's a ground rod right there. And then with your shack or your other connections, that if they're connected to ground rods, those ground rods must be connected. That's just not a you should do, that is a must. That's by code. If you have multiple ground rods, they must be bonded together. Okay? So this is kind of an example of if you don't do that, you can see there's two ground rods at the bottom. You see that they're not bonded together. If you have a tower or you have you've got the AC power lines that are coming in here, if you think about it, whether lightning hits your tower or lightning hits the AC and it's transiting through or past your shack, what's more likely? It's gonna come in, and what's the easiest path to go from one end of this screen to the other? It's through your shack, right? You might think, oh well, it's just going to go through the ground. The ground is huge resistance compared to the cables and wires that go up into your shack, through your house, and then out the other ground rod. So you want to avoid that. That's why it's so critical to make sure that your ground rods are bonded together, so that it doesn't just go right through your house and through your shack.
So they should be bonded not only to each other, the ones you put in, but you mean the ones the ground rod that's already there just from the service coming in.
Yes.
The house.
Yes. So the ground rod that's right underneath where your utilities electrical comes in, and the ground rod that you put in for your shack, they must be bonded together. And they would also add that you want to have a good rule of thumb is that for every double the length of your ground rod. So if you have an 8-foot ground rod, that you have a ground rod every, like if it's 8 foot, it would be every 16 feet you have another ground rod. And so until you've connected them all. And preferably, if you have a choice, you want your shack to be as close to your utility ground as possible, so that it's a very short connection, right? So again, it makes it easier for it just to go around or past your house, outside versus through your house. So here you can see again, this shows a proper example of how it goes around the house versus kind of through it. You see the multiple ground rods are all bonded together from one end to the other, and then connected to the tower as well. So like one point they make in there is like, well, should I bond my perimeter ground of my house to my tower? The good rule of thumb, they say, if your tower is closer than 40 to 50 feet, it needs to be also connected to the same perimeter ground. If it's further than that, it doesn't really make any difference. Just because it goes to there's a very high impedance, and that lightning is just not gonna go that path if it's further than about 50 feet. Rods and radials. So the objective model for a tower, if you have a tower, is you want to have 3 ground rods that are all bonded together. And I would also kind of make a point about, like you see the shape here, you don't want your number 6 bare copper that's connecting the different ground rods together. You don't want them to have any kind of sharp angles. You want to have nice rounded angles. And an even better thing, if you can do, is have radials that extend away from the tower. So in addition to those 3, you could have up to 30 feet of buried radials that again have additional ground rods at, again, double the distance of the length of each ground rod. So again, 8 foot, you'd have one at the next 16 foot out to 30 feet. Okay, and I mentioned before, if you have a tower, that you want to make sure that your coax is bonded to the tower at least every 50 feet. And they show an example here, like what is that? So you can see like that little bracket is connected to the tower, and your coax is screwed into that. So if there's some type of transient, that it goes into the tower, not blows up your coax. So this concept of the protected zone, this comes back from Ron Block's NR2B 2002 QST articles. So those you can find on ARRL's website for free, and it's a great resource. But they kind of goes into some articles that kind of go into this in detail. There's a couple key concepts: that every line that crosses this boundary must be protected by a common or bonded ground connection. This is where that single point ground panel comes into play. And then bonding the equipment within the station. So within your station, they're all bonded together. And then you can see the examples, like literally it's not just your shack, it's you have to look at all the wires that are around your shack. So the TV, the clocks, everything together, it's all part of that zone. So next topic is RF management. This is this is kind of the key point. You have to remember that literally everything inside your shack is an antenna, including you. You're going to be in the near field. So if you keep that concept in mind, you have to understand how to, like, how do I manage that so we don't have issues. And there's just this kind of just like an objective model of a shack here. So the key focus here is you want to make sure that everything, if you bond everything together, that's kind of one of the key principles. You want those connections to be electrically short and keep everything at the same voltage. This is what bonding does. Amplifiers, if you have an amplifier, this is extra important. There's high RF current that's there, and so it's going to take an additional effort to make sure that's handled properly. You want to create a common reference plane or bus. So talk things like reference planes. This can be a reference plane that you can use, or a bus like that people commonly hear about, like a copper tube that runs on the back of the shack and that you bond everything to. Same idea. Okay, so just a couple examples here. So, this is the common model that you see here on the right, where you have all your devices that are via ground clamps that are connected to this copper plumbing pipe that runs along the back of your shack, and then that in turn is connected, one connection only from that bus or ground plane one that connects to your single point ground panel, which in turn is connected to that ground rod. Well, what's the benefit here? Bonding inside the shack, it helps to eliminate those RF hotspots and reduces the RFI from common mode current, so the interference. Minimizing the loop area of the cables and length. You want to use short coil cables, use a bonding bus or reference plane. Shielded cables, especially important if you things like audio cables. Also short straps or wires. So this on the left here, you can see how this goes. So you might have your radio connected to your amplifier, and they all kind of go along this, and it's maybe a little bit harder to see, but you've got this bus bar that kind of runs on the back. You want to have all those things very close together with that, and keep those length of cables very short. So if you're setting up this way, you're gonna do better. This is actually Ward Silver's station. He used this in his YouTube video. But the thing to point out here is that's that little piece of flashing. It's kind of like behind the monitor back here. It's just simple. Just get a piece of aluminum. Just run that along the back of your desk, and the cables are just coiled on top of that. And your devices are physically connected to that same ground plane. It could just be that simple. So this is the W8JI is his shack, or his resources online are referenced in this book, and it's really I think a good resource where we can take a look at this and show you kind of like some different. Let me find my mouse. Okay, a number of different resources here, but I want to go through this model here of what does the typical shack look like? What can be better? So definitely, highly recommend going through this, just to at least compare what you've got here. So the common model, what a lot of folks have, is they have the radio room connected to a ground. There's a ground out there. Maybe you have a tower, and then you're getting your AC from the utilities. Now what's wrong with this? What's wrong with this model?
Two grounds.
Yeah, are those grounds connected? Are they bonded together? No. So if lightning hits, either it hits your tower or comes on electrical wires, you're inviting that lightning into your house, causing all kinds of damage to your radio room, or perhaps even some injury. But you're for sure going to blow up all your expensive equipment. So it's useful to look at this and go okay, I probably don't want to do that. So some of the better models that you can do, and this is when it's okay, we don't have unlimited resources. So the idea is you want to do better and better, and if you can, you want to do the best model that you can. So this is the better model. So here you see now we've got our service ground and our shack ground are physically bonded together, and this is for sure better. And I think a lot of folks, this is probably what they would do. You know, if I'm doing this, I'm doing good things. And you know, there's a fair chance that I can avoid damage if the lightning is not a direct strike and, you know, it's just a pulse that's in the vicinity. Oops. Better for gear, but the bonding's missing. Single point, oops, ground panel. Ground protection for all common power, telco, and antenna. But we still don't have the, so they go into details here, but I'm going to just jump down to the best model. And this kind of shows you the pros and cons, so please read this when you can. And the best by far. Okay, we've got our service ground bonded to the shack ground. If the tower is close enough, then we bond that as well. And you've got plug-in grounded outlet strip with internal MOB suppression. So, but the main point is look at this as a resource to, you know, this is probably a great, you know, looking at someone who's really done it well. Like in his discussion here, it's like he's got like multiple 300-foot towers. They get hit by lightning many times. Never lost any of his equipment. Okay, this guy's doing it right. So it's a good, I think a good approach is to try to emulate folks that have, you know, figured this out. So, and I think the only other slide I've got here is some, well, a couple more, just some do's and don'ts. Use heavy wire, strap or braid for the currents, mechanically sturdy. So if we're talking about, well, so just in general, you want to make sure you're bond your Hamshack grounding electrode to utility ground. Keep the wires inside your shack short. If you use braid, make sure that you protect it from moisture and chemicals because it can break it down. Bond the Hamshack AC outlet to the single point ground panel. In the book and on the video, they show this device. And this is the one I bought the same thing. But the idea here is that you plug this into your regular AC, and it's got a way you can ground this to your single point ground panel, right? So this is why this is among the reasons why they recommend this is you can actually ground this to your single point ground panel, which is a better configuration. This is a trip light.
Trip light.
Yeah.
Okay. So you connect into those little screws.
Yeah, and I'll pass this around. This is the one I use at my shack. Oops. You can see the connector on the this side.
Average price of that thing?
Oh, 60.
Yeah, I think that's probably about that.
60, 70 bucks.
Maybe like 120 bucks.
I think.
Really? I didn't. Well, they have ones that are for like medical devices. They're even bigger. And
Go to slideshow.
If we got $1,000 rig, I think that's cheap.
Yeah. Yeah. Well,
Look at trip light is, but trip light, they also, what they really make is battery backups for computers.
yeah.
A lot of the battery backup devices can be grounded too. So if you got a battery backup device, you can kind of have the same type of thing.
there you go.
Sam,
Yeah.
I attended a similar briefing, and the overall threat is it's conceivable, not exactly always the case, but if you don't follow or try to follow the best practices, and you get a lightning strike on your house, that your improper wiring and connections could invalidate some or all of your home insurance.
Well, so I think, I mean, and part of that I think is this key point is like throughout all of this, always follow electrical codes.
It's almost impossible to follow all of the electrical codes.
Yeah.
Because the National Electrical Code is a telephone book size
Yeah.
device. It's really hard to do that without, and you need like a PE or a certified electrician to come in and certify that work.
Well, they do, and Ward talks about this on the video, but one thing he does say is that whether you do it yourself or like if you have an electrician do some of this work, as far as like the AC wiring, if you can have an electrician come in and validate and make sure that you're within code, and so that is for sure something you'd want to do if there was any concern about that. But if you're for a starting point, if you're doing your planning based on like these objective like solutions that, you know, have been shown to be very effective, then I think you're going to be in good shape.
If you take no precautions or whatnot, you're jeopardizing your house insurance.
Yeah, yeah,
And you
definitely.
have, you know, fire or what would get from it. So this is something, this is serious stuff.
Yeah, serious, for
Are you
sure.
saying my insurance company would leave me holding the bag?
No, too bad.
Two bags, both bags,
I just
both
had,
hands.
our home electrical, we've had a whole new, they did all of our wiring.
That's right.
And we had like gazillion electricians at our house and they did also. And then when the city came and did their inspection, they found like 5 things that they had, they did that the city
Weren't
didn't
code.
agree with, yeah.
Yeah.
And they, so, you know, and the guy said, you know, the last time we did it, it's just like, but that they're, so you know, it's a really confusing. It depends on what inspector comes to your house. But they hooked up, we have a whole house surge protector.
Mhm.
And I'm not sure how that would fit into this.
Yeah, we don't get into that, but I've seen some resources. The idea with that one is that is meant to deal with, like, if you get a transient that hits your utility lines and that's coming in through your service panel, that it's meant to try to divert that surge directly into that ground rod, right? And then that's the idea.
And what you haven't talked about in this, that's the unknown, is what is your ground, your earth ground really made of?
Yeah.
Now,
So
mine, in my part of town, I only have like about a foot of topsoil. And then there's an immediate caliche layer.
Mhm.
And then there's some more stuff. And then there's another caliche layer.
yeah,
And so, and the house is, not my house, but the house has copper water pipe throughout it, laid in the slab and whatnot. The ground is the copper water pipe.
Yeah, that's what my house.
so yeah, if you have an older house, you can probably, and I've seen some say you can get away with that. So some of the problems is like seeing that you have a copper pipe is not, especially like a new house, is not a guarantee. It could go copper right to a certain point, and then it's PVC,
Yeah.
and then you're out of luck.
This is an older house,
Yeah.
I'm pretty sure. But I saw a house out in Walsh Ranch, out in that area, and there is no topsoil out there.
Yeah.
It's caliche.
So-
And I looked at the panel, and the panel was there, all the stuff was there, and a wire comes down to the ground, and the ground was a piece of stupid rebar.
Yeah.
How that was ever gonna pass, I don't know.
Well, but in that specific, go ahead.
They told me that our house has to have because I had a ground wire, I think that's what it was, a rebar. And they said, no, that's not good enough. They said you have to hook it to the copper pipes. And he had to run a wire all the way around the house to where there was a copper wire. And then
But do
I
houses-
tried to put in my ground, I got a copper ground wire when I was putting my grounds in for my station. And in some places, I couldn't get that thing deep enough. I was
Yeah.
kind of like rock.
So
But-
you have to do almost like a ring ground around your house to kind of get enough in there when the soil is so poor.
So in that case though, like there's one of the YouTubers I follow had this question asked, Dave Kassler, KE0OG.
Yeah.
Someone asked that specific question, that they weren't able to physically bury the ground rod straight down. In that sense, in that situation, what they discussed is orienting that ground rod horozontally.
In a trench?
Yeah, just as far down as you can.
Yeah.
And that's obviously, that is not ideal.
Yeah.
But you want to do, I think if you had multiple ground rods, as much as you can, that's good. Also, some newer houses, the other thing they talk about here, in the book is they'll have something called an UFR ground. An UFR ground, it goes back to World War II, the U.S. Army, especially in like a desert where you've got, that soil is pretty poor for grounding, that they put rebar within the slab, and all those rebars are bonded together, and you have usually like one connection there, and you can use that as well. That is a very good ground.
In fact, that's becoming code in a lot of areas.
Yeah. So if you have that,
New construction, they're having to do that and being required to use that as the ground for as the electrical ground for the house.
definitely, and that.
Now, you're saying that's a pretty good ground?
UFA ground, yeah. I mean, they came out of the Army. They in very, very poor grounding conditions.
I'm going to take some convincing on that, but I know that if the code committees come up and say you got to do it this way, they know something I don't know. But I mean, it just doesn't make sense that you're using the concrete.
Yeah.
Yeah, that's what they.
So
As your connection to ground.
it actually apparently is, though, a concrete encased electrode, which I think UFA is in that category. Just they've shown that it is very effective. So, and I'm not an expert, but that's what I'm told.
Yeah.
So, but if you do look for UFA grounds, I believe it's mentioned in the index. We do have another. There's a club version of this second edition, and there's about 5 versions of the first edition. So, if you want to take a look at this, there's not a whole lot of differences between the second and first edition. So, if you do want to borrow, take a look at this.
I think.
Yeah, it is in there. So
I think his object was to give these away.
Yeah. So yeah, the UFA ground is talked about. It's in here, so you can read up on it.
I'll look at it at home. I've got the book.
Our tick-B trailers, the ground for those were a half-inch stainless steel wire, stranded wire, and star-shaped stakes that ran all the way around. So you had a generator and you had a tower with microwave and all sorts of other antennas up there.
Yeah.
And that came out of the Desert Storm operations where you're in the middle of the sand, so you had to build your own ring ground around the
Yeah,
communications equipment.
Well, I know you were in the Army. I was in the Air Force. So we did tactical communications, and we did the perimeter ground ourselves. So at the network control center that we would set up on a deployed base,
Right.
we would literally put all the ground rods in and bond them all together.
Right.
And it worked. It's effective.
So essentially, I think you have to do something like that at home. If your soil is just like caliche,
Yeah.
crap, you're almost going to have to build your own temporary ground and tie that into whatever the AC service panel is.
Yeah. Well, and actually, that is another option.
Know how to drill through caliche.
Yeah, or just figure it out.
So if it's all caliche, you have to run your
Get a better drill.
or your water bill is going to be tough, kind of keeping that wet and connected to that.
There you go. So just a couple more slides. Always follow code. Bond your shack AC outlet to the single point ground panel. That's what that's about, and that's what's the picture in the book. Don't use internal components outside. So, and I see this often. There's a way to connect that you connect the to a ground rod. You often see you're supposed to use these acorn nuts, or even better, if you can, get these. They call them CAD welding, like CAD weld, like. Yeah, CAD welds. There's another type. Yeah, basically it's just a thermal, like it's like thermite kind of idea. Is that you can bury that and not have to worry about it anymore.
Those are supposed to be available at the major hardware stores, the Home Despots and the Lowe's or whatever. I mean,
Yeah.
but it's like you set your connection up, and you
Right.
put this thing over the top, and you hit it with a hammer, and it's a magnesium flare that burns everything.
Yeah, just like it's molten
Yeah.
metal,
Yeah.
and you could bury that without. So if you can do that, that's like best. If the simpler one is just buy those little acorn connectors, but you have to kind of inspect them every so often.
Yeah.
Don't use solder on any connections for lightning grounds.
Yeah.
So if you're connecting, you're connecting your tower to the ground rods, never any solder. Solder in lightning will just vaporize, and it's like, and then as soon as it's vapor, it's not you lost your safety connection. It's no longer bonded. Don't use exposed braid from old coax for bonding. This is just out of the book and in the video. That stuff, as soon as it's out, it'll start degrading. It won't be effective. Don't allow unprotected wires to cross protected zone. So that's the idea of like everything goes through that single point ground panel, that those wires are not in close proximity, they're separate, keep them separated. And the last slide here is just resources. This is the book. we have the second edition, this one copy, and multiple copies of the first edition. Ward Silver, this is a great video. If you watch that, this will probably this will look very similar because I borrowed heavily from that. Thank you very much, Ward. Buy his book. MikeHolt.com, this is mentioned in the book. This is a lot of great resources about electrical code. It's not about ham radio, but they also talk about ground, so there's some really good resources there. WHAI, that's the website we were just on. More about grounding, about lightning protection, resources on RF interference. We just looked at one page, but there's two other pages that are also very useful on there. This one just came out, this new ARRL Radio Lab. It's about 3 minutes. It's worth watching. You can kind of see like, okay, if I was to start from the ground up, this is a really cool setup to kind of like they've got like a server rack. They use like a server rack and they put all their RF type equipment in there, and then they have cables that run along these metal trays along the outside of the room to the desks. Keeps all the wires together, keeps all the RF stuff right in one spot. It minimizes, keeps all these wires short, and it's another good objective model for a way to do it properly. And I think that is that's the last slide.
Cool.
Again, go watch Ward's video. He does it. Again, if you're watching on YouTube, watch Ward's video.
Good job, Sam.
Yeah, you done good, Sam.
Good job, Sam.
I stand corrected, that one you have is $70.
Okay.
I was looking at some other ones, different applications that were a lot more expensive.
There you go.
That's standard. That's
What's the primary reason you have that one in your shack?
What?
They're mobbed, triple
Yeah.
mobbed.
So in my situation, it's probably less useful because, and this is probably a good discussion point. I live in an apartment. I live on the 5th floor. A lot of what you just saw is completely not applicable to me.
Right.
I cannot connect to an RF ground. And you might think, well, why don't if there was some ground, why can't you just run a wire to that? It won't be effective. Effectively, what you created is another antenna.
Yeah. But what you can do is tie everything to the ground to your electrical ground.
Right.
And make sure that your case and your power supply is really a ground, not some floating thing. So you can tie the case of the power supply, the lug nut on the back of your HF rig, and all of that goes to the same ground that's in your AC ground.
Yeah, what I can do, and this is what I do. So I can't do like a lightning ground, and to some extent I am protected because I don't have external antennas. All my antennas are internal, so I am protected by the building itself from like a direct strike. I use like a common plane like this. My radio is bonded to this. My tuner is bonded to this. I use all my connections for AC are just on that, so I do get surge protection, but I don't have a single point ground panel. But I do have issues, like the issue I have, so this is probably a really good example. I have to deal with RFI. So what I didn't really get into is maybe what a lot of folks will do is you just buy ferrite. And I have ferrite, snap-on ferrites, I've got toroids, type 31 toroids, and ultimately I've knocked out all my RFI. If you put enough ferrite on things, you can overcome a lot of the issues. But that's a compensating for not being able to do some of the things you would do in an objective model. It does work though.
I've had good luck with a line isolator, which is essentially a piece of PVC tube packed full of ferrite and other crap. If you put that between an HF rig and an amplifier, you're reducing the ground loops coming back on the outside of the coax.
Yeah, the common mode. Yeah, for sure. Yeah.
Common mode things.
Yeah, the ferrite.
Good luck with those. And I've run some even to the antenna outside goes through one of those, which helps reduce some of the noise coming in from outside.
Another way I compensate is I also keep my power down, so I don't run any more than like 25 watts, which for the modes I operate, whether it's digital or CW, it's actually pretty effective.
It's a safety issue too for you. These antennas in your apartment.
Well, right, and so that's another good point. We didn't get into it, but there's the RF safety. You have to do that survey.
Yeah.
And so I've done a survey, and I know there's the controlled zone and non-controlled zones. So for my neighbors, I keep the power down, so I'm within all my RF safety limits. So, yeah, good reminder.
Did you get a copy of that workbook I did, where you calculate what the RF exposure safety is?
I don't think I had that, but I'd already done it with the new system. There's some online resources. If you have questions on that, we can, Bud will be a great resource for calculating that. All right. Well, thank you, everybody. And
Great work.